Hello and welcome to lesson number 10 in Unit 2B, Quadratic Functions, Forms and Transformations in our grade 11 University College math class. This is how to graph a quadratic function given any form. So this whole first page, folks, is just a review of the three different forms of a quadratic that we've looked at, how to go about graphing them perfectly, and it's kind of just a review of all of that. We're not going to spend a lot of time going over this. Just very fleetingly, we're going to look it over. So the first one is a vertex form. The form you recognize, of course, is f at x equals a bracket x minus h all squared plus k. The point that is evident from that is going to be the vertex, which is h and k. The h value, of course, being the opposite of how it appears in the brackets. How do you graph it? Well, you put the vertex on there, you sketch through the axis of symmetry, you derive the plot pattern based on the a value, and you graph accordingly. The plot pattern, of course, being 149, and that is amplified by multiplying it by whatever a happens to be. Label at least 3 points, including the vertex. If it goes through x-intercepts and y-intercepts that are integers, so like whole numbers, then there are some occasions where you're going to label 4 points. Label the equation, and you're done. That's how you graph like a champ. Factored form, one of the new ones that we looked at in this particular portion of Unit 2, is in the form f at x equals a bracket x minus r bracket x minus s. The points that are obvious in this form are our x-intercepts, which are point r0 and s0. We can find the vertex in one of two ways. We can do the hack and slash method, which is halfway visually between those two x-intercepts will be your axis of symmetry, which is the h value, the x component of the vertex. If you substitute that back into the equation, it will spit out the y component of the vertex. And once you have the vertex, off you go. Similarly, you could find the vertex by taking r and s, the actual points or the actual x values of those points, adding them together and dividing by 2, which is a way of visual, or it sort of matches taking the average visually. This is an algebraic method for doing it. Using the a value to find the plot pattern once you have the vertex, you want to label at minimum 3 points, including the vertex, put on your axis of symmetry and label it, label the equation, and you're good to go. Standard form, in the form f at x equals ax squared plus bx plus c. We recognize that the y-intercept is obvious in this form of a quadratic. It is the constant value at the end, the c, so our y-intercept would be 0, whatever c happens to be. How can we get to the vertex from here? Well, we can complete the square. But if you don't want to do that, and in this case you don't really need to do that per se, you can use the cheat. And the cheat, of course, is the h value, the x component of the vertex, can be found by taking negative b and dividing it by 2a. Once you have h, you substitute that back into the equation to get the y component of the vertex. And once you got the vertex, it's the same as any of the other methods. When you have the vertex, you use the a value to inform your plot pattern. The 149 gets multiplied by a. So from your vertex, with the plot pattern, you're going to label the axis of symmetry, and you're going to label at minimum 3 points to as many as 4 points, including that vertex, and label the equation, and you're done. So in every form of the quadratic, we have a few things that are available to us. The first, of course, is the a value, which tells us our direction of opening, and it informs the plot pattern. So that 149, as we go out 1, 2, 3 units from our vertex, we can find not only the direction of opening, but how the plot pattern will be impacted by the a value. All three forms you can get to a vertex, which is the most important part for sketching the graph. So there's your review. What's the lesson / homework? Well, the lesson is we're going to be doing 6 graphs. 3 of them we're going to go over in the lesson, and the other 3 I have here in the completed version of my note. They'll be empty in your blank note, but they will be filled in at the bottom of the skeleton note that you get from our class website. So we're going to do one of each type of quadratic in our graphing, so let's just jump to it. So the first one we're going to look at is f at x equals 2 bracket x minus 3 bracket x minus 7. So what form of a quadratic is this? And I think maybe I haven't spent a lot of time talking about this, but when you have brackets and they are not squared, that's how you can recognize factored form. Brackets not squared. And of course I'm drawing a distinction between the brackets that you would have squared in vertex form. Now a lot of times students rely on the fact that there will be 2 brackets. This is not necessarily going to be true. For example, if I were to give you, obviously you don't have to write this down, if I were to give you x bracket x plus 3 close bracket f at x equals x bracket x plus 3. That's also in factored form. It just so happens that our first factor goes through an x-intercept of 0, which nobody would write. They would just let that bracket sort of collapse down. They'd even just get rid of the brackets, and you'd be left with just that x. So just make sure that you're able to identify which type of quadratic is which. So this one is going to be factored form. Factored form, as we know, gives us two pieces of information. Right off the bat, it tells us our x-intercepts. So our x-intercepts here are going to be the opposite of how they appear. So we're going to get 0.30. Now we're going to get 0.70. So let's start by getting those on the graph. 30 and 70. I'm going to hold off on the labeling till the end since I'm not 100% sure how the graph's going to look yet. Now, algebraically, I can find my h value by taking my two intercepts, adding them together and dividing by 2. So that's going to give us 10 over 2, which will give us 5. So the h component is going to be 5. Visually, I can see that, right? Because it goes halfway between these two x-intercepts that I've put on. And I can see visually that it's going to be 5. I'm not fussy about how you do it. You can do it algebraically. You can just do the hack and slash method where you just visually find the middle between those 2 points. Either way, it's fine by me. But there's our axis of symmetry, and I'm going to label it x equals 5. And now we need to find ourselves the vertex. So we have half of it. The other part of the vertex that we need to get, we are going to substitute our h value in to find that. So that will be 2, 5 minus 3, 5 minus 7. Working the brackets first, that gives us 2 and negative 2. So that will be 2 times 2 is 4 times negative 2 is negative 8. So my vertex then will be 5 and negative 8. And then we put that on the graph. So negative 8 down here somewhere. There we go. So now we have our two x-intercepts, we have found the vertex, and now we need to articulate our plot pattern. So our plot pattern, of course, is an extension of 1, 4, 9. Whoops, that's messy. 1, 4, and 9. And we modify that or amplify that by multiplying it by a. Our a value sitting out front is going to be 2. So we're going to multiply our 1, 4, 9 by 2. That means we go out 1, up 2, out 2, up 8, out 3, up 18. And I actually think we can fit all those points on there. So now we continue to graph using our plot pattern. So from our vertex, we go out 1, up 2 in both directions, out 2 and up 8. Those are the ones that take us to our x-intercepts, interestingly enough. And then we go out 3 and up 18. So that's 8. So we want to go another 10 up from there. And 10 is all the way up here. So there's that one. And then 1, 2, 3, 1, 2, 3. So there we have our matching points. So there is our tall, beautiful graph. Let's put some lines through this to make it pretty. I'll do my best. Trying to keep it. Well, it's a little wiggly. Oh well. That's the problem with the ones that have vertical expansions, is they get pretty narrow on your page. Oh man. This is much harder on an iPad than it is in real with real paper and pencil. Okay, so there we go, get some arrows on there. So we have our graph sketched out, we have our axis of symmetry labeled. We are going to label our vertex. So our vertex was at 0.5, negative 8. We're going to do our y-intercepts. They were at 7, 0, and 4, 0. That is a total of 3 points, and our y-intercept isn't displayed on the graph, so that's sufficient. Now we just want to label our actual equation. So f at x equals 2, x minus, oh sorry, that should be 3, sorry. That should be not 4, but 3, 0, there we go. 2x minus 3, x minus 7. So there we go, graph like a champion. That's 12 out of 12 right there. That's a beautiful graph. So when you come back, we'll have a look at vertex form and standard form graphs. So we'll see you in part 2.